Lagrange's linear equation. PDEs are the form. PDEs are the form PP Q is equal to R. PP Q equal to R, where capital P, capital Q, and capital R are either constants or function of x y z. Function of x y z. Capital P, capital Q, capital R are either constants or function of x y z here. And you know that small p is standard notation. Small p is equal to dou z by dou x. Small q is equal to dou z by dou y. Okay? That type of standard notation, we can see that here. Okay? I can see that. Therefore, in order to solve this kind of Lagrange's linear equation, to solve Lagrange's linear equations here, form an auxiliary equation. Consider an auxiliary equation. This is short way, but original procedure is method of separation variable. That idea we can follow that here. Form an auxiliary equation dx by capital P equal to dy by capital Q equal to dz by capital R. Consider an auxiliary equation dx by capital P, dy by capital Q, and dz by capital R here. Capital R here. These functions here. This is for x, y, and then z. In that manner, you can consider here. Suppose your R in the left side here, you have to put minus R here. Minus R here. Then apply uh, variables are separable procedure. Variables are separable procedure. Then apply variables are separable procedure, and get variables are separable procedure, and apply variables are separable procedure for the above three factors. For the above three proportions, and get two independent solutions, u and v. Two independent solutions, u and v. Then the complete solution is phi of u comma v is equal to 0. The complete solution is phi of u comma v is equal to 0. 0. Either clubbing first two proportions, you can after solving that you can get a solution that will be u, or you can get first and third, or second and third. With the help of that proportion, you can get a solution. You can get a solution v. Then the complete solution can be given by in terms of function formula. Function of u comma v is equal to 0. Function of u comma v equal to 0. That will be the idea here. That will be the idea. Suppose method of variables are separable. Suppose the method of variables are separable is impossible for the given proportions, for the given auxiliary equation. Then apply then apply algebra of proportions. Algebra of proportions. Apply algebra of proportion and construct possible proportions. Construct possible proportions through this. Construct possible proportions through this, and then find independent solutions through the
Sir,
newly obtained
sir,
proportion. Through the newly obtained proportions. Suppose the method of variables are separable is impossible for the given auxiliary equation. Then apply algebra proportion and construct possible proportions through this, and then find independent solutions through the newly obtained proportions. Okay? Newly obtained proportions. This is one way here. Another way is method of Lagrangian multipliers. Method of Lagrangian multipliers. Method of Lagrange's multipliers. Suppose both algebra proportion and method of variables are separable. Method of variables are separable are ruled out. Then choose two pair of numbers or variables L comma M comma N and L dash comma M dash comma N dash, such that you have to choose these two pair of numbers, the LMN or L dash M dash N dash. Not only numbers, it may be X Y Z or X square Y square Z square, that type of thing here, such that LP LP plus MQ plus NR equal to 0, and similarly L dash P plus M dash Q plus M dash R equal to 0. Therefore, you have to choose three LMN or L dash M dash N dash, such that this LP plus MQ plus NR equal to 0. Similarly, L dash P, M dash P plus N dash R equal to 0 here. Okay? N dash R equal to 0. Then dx by P dy by Q, this is auxiliary equation. Auxiliary equation becomes dz by R. You can, with the help of these numbers, you create proportion here, algebra proportion L dx plus M dy plus N dz LP NQ plus NR. Because algebra proportion, we're adding L here, N, M here, N here, and then adding here. Then here is also, you have to put in the denominator is also same thing here. But this value equal to 0. Already you know that this value equal to 0. For M dy plus N dz whole divided by 0. MQ LDX or MQ. MQ. MQ LP plus MQ plus NR. Here L dash P M dash Q plus N dash. Is LP plus MQ NR by 0. This part is already 0. This part is already 0. Therefore, you combine any two proportions. Combine any two proportions. You can get you club 1 and 4 to 1, fifth one, 2 and fifth, fourth and fifth. Anything if you club, if you can consider two proportion, you can get this part only 0. This part only 0 here. LDX plus MDX. Then comparing, then considering any proportion with the last one, we get the last one numerator obviously becomes 0. MDI plus MDZ equal to 0. MDZ equal to 0. This part cross multiply, you can get 0 here. 0. Integrating implies LX plus MY plus NZ equal to 0. NZ equal to, sorry, A, some arbitrary constant A. So this is one of the independent solution. This is one of the independent solution. You take it as this as a U here. U is equal to Lx plus My plus Nez. Nez. This is one independent solution. Similarly, we get L dash x plus M dash y plus N dash Z equal to some B. Therefore, our solution is pi of U comma V. You say U equal to U, say independent V, say pi of U comma V is equal to 0. Pi of Lx plus My plus Nez comma L dash x plus M dash y plus N dash Z equal to 0. That will be the solution you can get at. This is the way you can identify solution of Lagrange's linear equation of P equal to R. This is the constant. To solve this equation, you have to form an auxiliary equation dx by P dy by Q d by R. Dx by P dy by Q dz by R. Dz by R. That is called Lagrange's linear equation and auxiliary equation you have to form here. Then under these three proportions, suppose variables are separable, procedure is possible for collecting any two proportions here. Then apply that, then you can get solve. You can get solutions here, U and V. Can get solution, and then the complete solution is pi of U comma V is equal to 0. Suppose that area is not suitable, you can apply algebra proportion. Get some possible proportions and then solve that one. That is also not suitable. Then you can use you can find two set of numbers, LM and L dash M dash N dash as that LP plus MQ plus NR equal to 0. And here algebra proportion we are
Sir,
using here. Numerator.
voice is breaking, sir.
Mm, wait. Is it okay now? Somewhat okay. Now is voice clear now?
Yes, sir. Yes, sir. Yes, sir.
Okay. Algebra proportion again we are using here with the help of these three numbers LDX plus MDY plus NDZ and get 0. Obviously denominator gets 0 because LP plus MQ plus NR equal to 0. Therefore, this way you can get two independent solutions here. That solution is function of, you write the solution always in terms of functional form for this type of Lagrange's linear equation here. Lagrange's linear equation here. Because if you eliminate a function from this, you can get Lagrange's linear equation. Lagrange's linear equation here. Therefore, you write everything in terms of functional form here. Function form. Now we take some problems based on this idea here. P root x plus q root y equal to root z. Root z. Given PDE is of the form P capital P plus Q equal to R. Capital P is equal to root x. Capital Q is equal to root y. Capital R equal to root z. Therefore, auxiliary equation is dx by capital P, dy by capital Q, dz by capital R. Dx by root x, dy by root y, root z. Therefore, you take any two proportions, but we have to get two set of proportions, these two and these two. Yes, variables are separable. That is possible here. That is possible. By first two proportions, dx by root x, dy by root y. Integrate implies, because already variables are separable form. Integral x power minus 1 by 2 dx equal to integral y power minus 1 by 2 dy. It will be minus 1 by 2 plus 1 by 2, plus 1 by 2. 1 by 2, 1 by 2, and so on. Plus equal to plus a or so on. Plus a or so on. Therefore, you can get it as root x minus root y. Root x minus root y. Root x minus root y. If you take 1 by 2 as a common element here, equal to some c. C is equal to c is equal to 1 by 2 a here. 1 by 2 a. You can get it as 1 by 2 a here. Therefore, this will be that one independent solution here. Therefore, u is equal to root x minus root y. This is one independent solution. Similarly, by taking last two proportions, dy by root y, dz by root z. Root z. Integrate implies you can get it as y power 1 by 2. Y power 1 by 2 by 1 by 2. Z power 1 by 2 by 1 by 2 plus b or so on here. Or you can get root y minus root z equal to some k equal to v say. Therefore, v is equal to root y minus root z. Therefore, your solution is pi of u comma v equal to 0. Implies solution is function of u is root x minus root y minus root z. Root y minus root z equal to 0. Root x minus root y minus root z equal to 0. That will be your solution. That will be your solution. Okay, right. Here already everything in the proper variables are separable form. Therefore, it is very easy to get two independent solutions. What is independent? Two independent solution means you cannot write this v, v or u. Suppose this is u, say you cannot write u or v in terms of another one here. You cannot write v in terms of purely u. Similarly, u cannot be written as purely in terms of v. If it is like that, you can say that it will be independent here. Here root y is okay. Root y, suppose you can write root y as a u minus root x, u minus root x, but extra root z is also there here. Therefore, if it is purely in terms of u, if you write that this part, then it is not independent. It is not independent. So that thing is very important. That thing is very important. Okay, right. This is the idea you have to get that. If these variables are separable, you can easily adapt here. You can easily adapt. We have another problem. Y square z by x t plus xz cube equal to y square. These are the one pp plus qq equal to r. pp equal to qq equal to r here of the form p equal to y square z by x, q is equal to xz, r equal to y square. Then auxiliary equation is dx by capital P, dz by capital Q, sorry, dy by capital Q, dz by capital R. Capital R. Implies dx by capital P, I can get as y square z by x here, therefore we can get x dx. dy by capital Q, x z. dz by I can get as r y square. Y square. Y square. Yes, if you club these two proportions here, z get cancelled. You can multiply y square here. You can cross multiply x here. That's okay. Similarly, second and third proportion not suitable. Another independent solution. If you consider that here y square dy okay, but x z dz not purely in terms of z. Z okay, but extra x is there here, therefore you cannot integrate. The only thing is that you can use first and second. Similarly, first and third you can try. Y square get cancelled. Z dz x dx you can get that. Therefore, first second, first third. This is not suitable. This is not suitable. Therefore, by first and second proportions, first and second proportions, x dx by y square z, x dx by y square z equal to dy by x z. Integrate implies x cube by 3 equal to y cube by 3. X cube by 3 equal to y cube by plus c. Or otherwise you can write x cube plus y cube is equal to a equal to u, or u is equal to x cube minus y cube. Similarly, by first and last proportion, by first and third proportions, or you can get x dx by y square z. equal to dz by y square. Dz by y square. This y square get cancelled. For x dx is equal to z, you can club here z dz. Integrate implies x square by 2 equal to z square by 2 plus a. For x square minus y square equal to b equal to v, say. For v is equal to x square minus y square. Therefore, solution is pi of u comma v equal to 0. Implies pi of x cube minus y cube. X square
X
minus
square
y square
minus
equal
Z
to
square.
0. Just a minute. X square minus z square. X square minus z square. X cube minus y cube. X square minus z square equal to 0. It will be z into x minus y. Solve z into x minus y equal to p into x square minus y square. Sorry, p into x square, px square minus qy square. Not px square y square, px square minus qy square. Px square minus qy square. Given PDE of the form PPQQ equal to R, where P equal to x square, Q is equal to minus y square, and R equal to z into x minus y. Then auxiliary equation is dx by capital P, dy by capital Q, dz by capital R. Dx by x square, dy by minus y square, dz by z into x minus y, z into x minus y. Here no problem, x only, y only. So first two proportion you can get answer here. Can get answer. Similarly, if you glub second and third not suitable, you cannot cancel y, and here both x and y involved, and here is also y, here only z, but here both x and y involved here. Similarly, first and third directly if you consider, you cannot get here. So therefore, here one proportion is possible with the help of variables are separable. One proportion is possible with the help of variables are separable. One solution is possible, not one proportion. One solution is possible with the help of variables are separable, but another solution you try for algebra proportion. Anything is possible here, right? By first and second proportion, dx by x square equal to dy by minus y square. Integrate implies x power minus 2. You can get x power minus 1 by 1 minus y power minus 1 by 1 plus a constant c. Right. Or here you can get it as minus, and here minus these two are, you can get it as minus 1 by x minus plus 1 by x plus 1 by y, plus 1 by y plus a constant, plus a constant. Or otherwise you can write 1 by x plus 1 by y equal to some constant here, c. Or 1 by x plus 1 by y, 1 by x plus 1 by y equal to a, that's equal to u say, u say. For one of the solution is 1 by x plus 1 by y, 1 by x plus 1 by y. One of the condition is 1 by x plus, solution is 1 by x plus 1 by y. But for another solution, you cannot use any two proportion directly by using methods. Variables are separable. But any algebra proportion is possible. You think that here, yes, here If you consider algebra proportion dx, algebra proportion means add numerator, similarly subtract numerator, that manner multiply numerator and add, depends upon that you can proceed. For here, if you subtract these two, dx minus dy, you can get x square minus y square, and here x minus y, that type of term is present here, somewhat possible. Okay? But to get another one by algebra proportion, further by algebra of proportion, dx by x square dy by y square minus y square minus y square dy by minus y square dz by z into x minus y dz by, you add these two, dx plus dy, dx plus dy, because x square minus y square we are getting here, x square minus y square. This dx plus dy can also be written as x plus y, x minus y, x plus y into x minus y, a plus b, a minus b form. Now you glove these two proportions, these two proportions, x minus y get cancelled, dz by z, and here's also d of x plus y by x plus y. So by third and fifth proportion, therefore by third and fifth proportion, third and fifth proportion, dx, sorry, dz by equal to dx plus dy, dx plus dy x minus y. This x minus y get cancelled. Here you can write d of x plus y by x plus y. Dx plus dy can be written as dx plus y by x. Integrating implies log z, log z equal to log of x plus y plus log c. Log c. You can write it as z by x plus y. Z by x plus y is equal to c, equal to v say z by x plus y dz, z by x plus y. I can get that here, and then I can get c. Therefore, equal to v say this is v. Therefore, solution is I of u comma v is equal to 0. U is 1 by x plus 1 by y. U is 1 by y plus 1 by y, comma v is z by x plus y, z by x plus y equal to 0. That will be the idea we can use. That will be the idea we can use. Okay. In this problem, you have adapted both variables are separable. You have adapted variables are separable. One solution by variables are separable. Another solution by based on the proportions we have adapted algebra proportion. Algebra proportion. With the help of that, we are identifying another independent solution z by x plus y. Z by x plus y equal to v say. V say. The same manner, can you give any idea about our answer? All of you noted down this problem is over. This problem. Pz solve Pz plus Qy equal to x. Pz plus Qy equal to x. Can you give the answer for this one? Okay? P is a very simple problem only. Pz plus Qy equal to x. What about the first solution?
X square minus Z square, sir.
Very good, very good. X square minus z square. Very good. Second, variables are separable possible?
No, sir.
No, very good. And then what about your idea?
Y by x plus y, sir.
Y by x plus y. Okay, very good. Very good, very good. Okay.
Sorry, y by x plus z, sir. Z.
Y by x plus z. That is correct. Y by x plus z. We can use algebra proportion dx plus dz. Dx plus dz. Then you can get z plus x or x plus z. Then you can club with any one other proportion. Any one of the suitable proportion. dy by y, that is possible. Therefore, your solution is pi of x square minus z square, comma y by x plus z. One is by variables are separable, another one is by algebra proportion. Right, very good. Very good try. Now, so far you have solved some Lagrange's linear equation with the help of variables are separable and by algebra proportion here. Suppose if you consider the problems like this here, solve x into z square minus y square p plus y into x square minus z square q would z into y square minus x square. It is also of the form pp plus qq equal to r. Given PDE is of the form P equal to x into z square minus y square, y into x square minus z square, and r equal to z into y square minus x square. Then auxiliary equation is auxiliary equation is dx by capital P capital R x into z square minus y square dy by y into x square minus z square root dz by z into y square minus x square. Z into y square minus x square. Then you see that variables are separable. Yes, definitely not suitable because all the combination of variable is present in each and every proportion. A is also x y z, A is also x y z, A is also x y z in the addition, the linear combination. But definitely variables are separable, not suitable for this one. Then algebra proportion, you may think about because somewhat lengthy expression. Therefore, directly if you add and subtract here, you cannot get easily here. But another one is Lagrange multiplier method is there. You have to choose two set of two pair of numbers. Numbers are variables L, M, N, L dash, M dash, N dash, such that LP plus MQ plus NR equal to 0. It may be variable or number, that is your choice only, but you have to choose like that. Here you see that if you glub uh, here x is z square, suppose if you eliminate this x, y, z here, x, y, z, if you add everything here, p plus so on, then z square minus z square 0, y square minus z square 0, x square minus x square 0. Therefore, if you eliminate this x, y, z means one factor is, one element is what is, what about your idea? 1 by x, 1 by y, 1 by z. 1 by z. Therefore, if you choose element as a 1 by x, 1 by y, 1 by z, you can get 0. LP plus MQ plus NR equal to 0. Another one is, any idea? X is z square, x square is z minus x square is z, x minus xy square, x square y plus x square y. Any idea? Hmm?
1 1 1.
Not one, no, no. You have to multiply by x here. You have to multiply x here, multiply y here, multiply z here, and you can get x square, z square. Here is also x square, z square you can get. Similarly, x square, y square can get negative. Here x square, y square positive can get here. Therefore, here already y multiplied minus z square, y square plus z square, z multiplied z square, y square minus plus cancel. For another suitable one is L dash M dash N dash is equal to X Y Z. X Y Z. That is a possibility. For you have to choose X Y Z. X Y sorry L M N L dash M dash N dash. L M N L dash M dash N dash by this way. This way. Correct. Here. Choose LMN. LMN as a 1 by x, 1 by y, 1 by z. Then we have LP plus MQ plus NR. NR equal to 1 by x into x z square, x into z square minus y square, 1 by y into x square minus z square, plus 1 by 1 by z into square minus y square 0 0 0 Therefore, we get by this proportion we get L dx plus M dy. Already you know the procedure. L dx plus M dy plus M dz equals 0. 1 by x dx, 1 by y dy. LMNR 1 by y, 1 by x, 1 by y, 1 by z. Integrating implies it will be log x, log y, log z equal to log a. So xy z equal to a, that is equal to u, say. For u is equal to xy z. One solution is xy z. Similarly, if we choose L dash M dash to x y z, x y z, then we get L dash p plus M dash q equal to 0. L dash p M dash q plus N dash r equal to 0. Then L dash dx plus M dash dy. L dash is x, M dash is y, z. Integrating implies x square by 2, y square by 2 plus z square by 2 is equal to some c. Constant. Implies x square plus y square plus z square equal to b, that is equal to v. Implies v is equal to x square plus y square plus z square. Pi of u v equal to 0. The construction of PDE, formation of PDE, initially we tried this kind of problems. Pi x y z x square plus y square z square equal to 0. You have written x y z as a function of the one, then eliminated that arbitrary function. In that case, definitely you get some this kind of equation P Q R. You can club P, you can club Q, you can get R. Therefore, and formation equation also you can get same equation. For Lagrange's linear equation, you have to get a solution in terms of functional form. Pi of x y z square y square plus z square equal to 0. For you have chosen 3 multipliers, okay, because more combination, more linear combination of expression is there. So you have to adopt multipliers LM L dash M dash N dash. That is your choice. Okay? That is your choice. Depends upon that. You have to get 0. You have to get denominator 0. Sometimes this is variable, this is number, this may be number. It is, depends upon the expression you have to choose. Sometimes it will be number, sometimes variable, sometimes both are numbers, both are variables, sometimes one variable, one number, one set is number, that manner can be.